Hey, good morning. We're taking a look today at the second part of section 1.6, dealing with absolute values. Today, we step it up from the equations to inequalities. So, a lot of things are going to be the same with this. One main difference is going to be our inequality arrow. So, when we're looking at these, okay, for instance, in our first one, we got the absolute value of 2x plus 7 is less than, how do we remember less than again? Oh yeah, the arrow is pointing at the inequality, at the x. You are less than me. That's kind of the way we can look at it. So our first equation, exactly the same, just like we did the last time. Okay, 2x plus 7 is less than 11. Didn't change a thing. Notice, again, I'm not changing signs here. That's one thing I notice sometimes students do. They're like, ooh, everything's got to be positive, so if they see a negative, they want to change it right away in there. That's only the value that comes out, only the value, okay? And, so first thing to learn, okay? If you have a less than, or equal to, that is an and statement, okay? We're going to have some hints we're going to look at here on what, I'm going to turn this a little bit because I keep looking that way. Some hints on what our graphs are going to look like, what our solutions are going to be. So making these connections for and or are going to be important. So and is less than. When I get to the second one, I start looking. 2x plus 7, okay. Ooh, two things are changing. The arrow is flipping, okay. Notice the arrow, flip directions. And we're still doing what we did before with the equations. Okay, we're still doing the switch from positive to negative. So two changes. Flip the inequality, negate the solution. Once we do that, now everything is just the way that it was before. We're solving these. So, go ahead and get my 7 out of there. Okay, get that one done. And then we'll go ahead, we'll do the same thing on our second one over here. Again, get that x by itself. Whatever we do to one side of the inequality, we've got to do to both. And just a reminder, okay? Because I know sometimes you'll hear me say these things and your brain will say, hey, look, there's a negative. I got to flip the arrow. Not this time. We only flip if we're dividing both sides by a negative here, or multiplying in some cases. So when we start to understand what all these things mean, when I finally get my math work done, okay, solution, what's that? That's just writing x is less than 2. Getting an and in there. The word in the middle you're going to see is going to become very important, and x is greater than negative 9. Okay? When we go to graph, we always want at least 3 numbers. We want to have number sense. You're like, okay, so what does that mean? It means whatever the space is between our numbers has to be the same. You can count by 1s, you can count by 5s, 2s, in this case 10s. But don't do like negative 9, 0, 2. Bigger gap in here than in here. We don't want to do that, okay? So I look and I go, okay, x is less than 2. Back from when we did the inequalities, less than is left. They both start with L. So I go to 2, which is about here. Just reminders again. Let's put them up here too. If it's just greater than or less than, those are parentheses. If it's or equal to, those are brackets. Okay. You'll start to notice a lot of things in here are going to repeat and spiral back through. And so if we miss something the first time and catch it the second time, you're like, oh yeah, that's how that works. So x is less than is left, 2. So less than is left. And x is greater, for eating x, greater, get bigger here, greater than negative 9. Greater than goes to the right. And what's typically going to happen with our and statements are, they're going to come together. They're going to clash in the middle. These two arrows are going to go, and basically it just means Our solution set are the answers between these two endpoints. And so when we do the interval notation for this, the last part, remember, interval notation, we go from left to right on our graph. So, left, we're starting at -9. Keep the same symbols you did on the graph. That's why it's important to graph first, so you've got that visual. To right. That is typically what interval notation for an and statement is going to look like, with a very small exception, which we will tackle here in a little bit. So that's our deal with and. Or there's a lot of things that are the same. My setup is the same. First one, just copy. Second one, flip your inequality arrow, flip the sign on your solution, solve them, just like we did before, no big thing. Now, just as an FYI for those of you that do these or have been doing them in practice, and then you're looking at Mr. H's solutions, which I hope you're doing. Typically with me, I tend to keep things in fractional form. I am not going to tell you that you are wrong if you have like x is greater than 3.33. That's fine. These are equivalent. 3 1/3. They're equivalent. I just got to get used to knowing, hey, Mr. Hardy, I got this, you got that. Are they the same? Punch this in your calculator. If you get the decimal back, yeah, they are. Just keep isolating that variable, doing to both sides what we do to one. And get each of those solved for. And then just like we did in the first example, again, not a lot is going to change. X is greater than 10/3, or, still need the words in there though, x is less than or equal to, did I lose my or equal to? I did. Detail, but an important one. See, yeah, I even do it. I really got to watch it here. So, okay, what's going to happen with or? So I got 3.33, I got -2. What am I going to count by? I think I'll count by 2s. Notice I don't have to just use 3. I can use more. I could do 1 for everyone if I wanted to. And so once I get here, again, I've got to know my basics. X is greater than or equal to, bracket, 3.33. So greater than, greater, numbers get bigger on a number line as I go to the right. So that's what we're going to have there. And then x is less than or equal to -2. Less than goes left. So, okay, we're learning a little something here. No, I'm not good at dance moves, but here's kind of how I do this with motions. So, and we said came together. Okay, we get one big graph. It all comes together. And, however, with ors go out. Okay, they both start with O. So, and, or. And, or, okay, you're like, enough of that, Hardy, I can't unsee that. Okay. And then again with our notation, our interval notation, left, arrows. What do arrows mean when we're on graphs? Arrows are infinities because they go forever. So forever left, here I'm coming to the right. I get stuck at -2. And then since there's another piece, I have to let people know, okay, there's another piece still that is union. Start up here, again, fraction, decimal, doesn't really matter, and off forever to the right. Big interval notations, big graphs on ors, okay? Smaller interval notations, smaller graphs on ands. It's just kind of a heads up. Okay. I know some of you are like, dude, get going. You got to kick some things into gear. But I like kind of giving you some background. You can always fast forward me if you need to. Okay. So now I want to throw a couple of the exception ones in here on you, just to get you thinking a bit. So we're going to go to number 2 down here. So I get down here, and you're like, wait a minute, I remember something. Hardy said something about if at the start of your problem, okay, if there's a negative at the start, okay, that's going to do something weird. Right, because we talked about whatever comes out of here is 0 or positive. We talked about this in the last section. Well, is 0 greater than or equal to -4? Well, yeah, 0 is bigger than a negative. Is a positive number greater than or equal to -4? Yes, it always is. So since 0 or a positive number is always greater than -4 or any negative number, my solution is everything. There's not a number that I can't plug in for x that isn't going to make this true. I could plug in a negative, it's going to be greater. I can plug in 0, it's going to be greater. I can plug in a positive, it's going to be greater. So what does that mean for my graph and all these other things? It makes them really easy, actually. If the graph is all the answers, the whole line is my answer. Okay? How do I do that in interval notation? Well, forever left, forever right. Okay? So you're like, okay, so anytime I see a negative, it's just this. Hang tight for a second. Okay? Keep 2 handy because we're going to look at number 3. It's close to being the same thing, but not quite. So let's see if we can keep them both on the screen here. So as we spoke about before, absolute value equations or inequalities, you need to isolate your absolute value first. So in this case, that means getting that 8 up out of there. Now, before you look at this and say, ooh, it's like number 2, there's that -3 right there. It's got to be these answers. Think about it for a second. Is 0 or positive? Is 0 less than -3? Well, no, I'd rather have no money than owe somebody $3. Okay. Is a positive less than -3? Well, no. Well, wait a minute, that's both false. False, 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 which is true. That seems kind of funny. Which is correct. Let's put it that way. So 0 or positive is, not always, is never less than -3. Never. What happens when something never happens? That is no solution. And I apologize, my last parts of the graph and interval notation went to the next spot here, so I'm just going to draw them in here. My graph is just a blank graph, okay? So for my graph, I'm going to keep it blank because there are no solutions. There is not one number, one value that works for this, that makes it true. So my graph just stays blank. Well, what about my interval notation? Empty set. Okay, that's how we say there's no solution. I mean, I guess if you wanted to, I've never seen this before. I guess you could write 2 of these with nothing in it, but yeah, this is going to be much more like what we want to do. Okay, excuse me for a second there. So I got one more I want to look at with you, one more twist, and then I will leave you to try some of the practice and kind of see what's going on here. So this one, we got a couple things to practice. First, isolate my absolute value before you split. If you split it before, half your answer will be right, half will be wrong. I'll guarantee it. So we don't want you in that situation. Okay, so we get here, positive over here to start, so we can actually do this one. So you're not somewhere else as far as that goes. So when we do setup, copy the first. Don't touch a thing. And then, ooh, let's try something here. when the absolute value is greater than, when it's eating the x, is this going to be, did I just say it? I think I did. Maybe I didn't. Is this going to be an and or an or statement? Let's go back and look for a minute. Okay, absolute value is greater than. Greater than is or. Okay, less than is and. Greater than is or. All the clues just to help me. And this helps you when you're working on the stuff online or with the quizzes or with the practice. It's worth your while to jot this stuff down. So this is an or. We always want to get the and or the or in there. And then again, copy what you see. Don't change that yet. Okay, not until we get answers out. Flip your arrow. Change the sign of your solution. And again, if you have colors, I'd do that just to get it into your brain and get you thinking about it some. From here, we just solve them. Minus my 5. Now here, be careful. Multiplying by -1, what's the opposite? Divide. And when we divide by a negative, we flip the arrow. Myself a little note there. Okay, that's the good thing about notes. Minus 5. Negative x. I like to put the 1 in front to remind me there's a number there. Again, divide by -1. Flip. Write it out in words until you get used to it. X is greater than 7. So there's my solution. And again, I'm going to try and get our graph and interval notation on here. We'll see how successful this is. So 3 and 7. Maybe I can count by ones this time. We got flexibility. And now again, in my brain, remember, if it says or goes out. Reminder. Or goes out typically and comes together in the middle. Again, if you have this stuff, use it as you're doing the assignment. Just saying, it's going to make your life easier. X is less than 3. Less than goes left. X is greater than, chomp, 7. Greater than goes right. Yep, that's the way it's supposed to look. And then my interval notation, left, -infinity to right, 3. But I got another piece, union, 7 to infinity. Okay? So again, lots of little pieces, okay? 2 expressions. Is it and or? What way is the arrow going? What's that going to make my graph look like? But that's why the practice is so important. Or go back through these, okay? Or even better yet, just have them available when you're working on the practice, okay? Which is on the next page. Same stuff we were just doing. Watch for your negatives and stuff. You've got this. Thanks for checking in with me. We'll see you next time.